Hi, so we're ready to look at section 5.6, which is the last section that we'll cover before midterm 1. So midterm 1 will cover sections 5.1 through 5.6. So what we're going to look at here, so if you remember in section 5.5, we looked at graphing cosine and sine and went through some examples. In this section, we're going to look at secant, cosecant, tangent, and cotangent, right? So the reason why we did sine and cosine first, that you're going to find, is that secant and cosecant depend on graphing cosine and sine, being able to do that okay. So if you look here, objective 1, we're going to look at graphing secant and cosecant functions. And I took the same table that we had before, so where we have these various x values, cosine and sine, in section 5.5. And then what I did is I added 2 more columns, secant x and cosecant x, and then filled in the appropriate values, right? And you might be wondering, well, how do I get these values, right? So so we already looked at, finding these by the unit circle, right? So then, for example, if I know that, cosine, oops, let me use maybe red. Cosine of pi over 6 is equal to radical 3 over 2, right? Then what if I'm trying to find secant of pi over 6, right? So it's important to remember that secant of pi over 6 is equal to 1 over cosine of pi over 6, right? It's just the reciprocal. So this would be equal to 2 over radical 3, right? But then I need to rationalize the denominator, so I multiply top and bottom by radical 3 over radical 3, and I end up getting 2 radical 3 all over 3, right? So 2 radical 3 over 3 is what I have here in this column, right? So I'd have to do those for everything. Also, just something to note is that, like here, if like cosine of pi over 2 is 0, that means that 0 would be in the denominator then when you flip it, right? So that's what makes that undefined, right? So you'll notice these pairings like here with the 0 undefined items, right? So those are paired up, right? And then we just do the same thing for cosecant, right? We just take the inverse of, the reciprocal of sine, multiplicative inverse. Right, so I filled in this whole table for us already. So what we can do is take those tables and start to graph the two functions, right? So you can see on the next page, this top function, we have this top graph, we have 2 functions graphed, right? We have cosecant, which is the blue line, and then the dashed line, that's actually graphing sine of x, right? So if you start to graph these, we get these points, and you'll start to see the shape, right? So it turns out, so that's what I have in this box here, right? So it just says, notice that the relative maxima and minima from the sine function correspond to the relative minima and the sine for the cosecant function, right? So what we're just realizing are these points here that I'm putting in red. Notice, so like if I focus in on this one at pi over 2, that is a maximum for sine of x, but it becomes a minimum for cosine of x, right? You can see how those are related, and that same point exists on both graphs, right? Another thing that you'll notice is that the x-intercepts of the sine graph give the location of the vertical asymptotes from the graph of y equals cosine x, right? So let me maybe do this in green. So you'll notice where the function sine crosses the x-axis, the x-intercepts, that's where we have these asymptotes, right, where those are located, right? So graphing sine first, sine x, will help me graph y equals cosecant x, right, using those, the relationship. So you'll notice if I look down here, it's very similar with secant and cosine, right? So I want to graph cosine first, and then secant, follows with those similar characteristics, right? So like where the asymptotes are and the max and mins, right, in the overall shape. So then here at the bottom, just have a table with some important information. So for cosecant and secant, we can find what the domains are, right? And so basically what we're saying is that x can be anything except the x can't be on the vertical asymptote, right? So that's what this part is meaning, right? Because sine is equal to 0 for multiples of pi, right? So if we look up here, where these occur, these x-intercepts, they occur at multiples of pi, right? So we have to throw those away. And then for cosine, the x-intercepts occur at odd multiples of pi, right? So we have to throw those away, right? That's what this is saying, right? And then the range for both of these is that y is less than or equal to -1, or y is greater than or equal to 1, right? And that makes sense, right? Because if you're looking at the graph, there's nothing in between these two values, right? But there is a value at 1 and -1, right? So this would be essentially like an open circle here and here, and then shaded in between. This is excluded, right, from the range. And then so there's no amplitude here, right, because it increases without bound, right? So it's just, it's increasing, decreasing, it's going upward, as far as it can go. So there's no amplitude, right? And then the period remains the same. We still get the same graph every 2 pi, right? And then here, these are just equations for finding the vertical asymptotes, right? So that's connected with the domain, you'll notice. And then something kind of interesting is that sine is an odd function and it's symmetrical about the origin, and cosecant follows that, right? And then if you remember, cosine is an even function, and its symmetry is about the y-axis. Its inverse function secant also follows that, right? So that's a pretty interesting part here. Right. All right, so now what I have are some examples to practice graphing secant and cosecant functions. So with example 1, we want to graph y equals 2 secant of 4x, right? So, the first thing we want to do, what we really want to do is to graph y equals, it would be 2 cosine of 4x, right? Because if I can graph this function, then that's going to help me graph secant, right? By using those characteristics we looked at before. So this is the reciprocal function, right? So to be able to graph cosine, right, some things that will be helpful for me to remember and know. So we need to know what the amplitude is, and also what the period is, right? And it's important here since my c value and my d value are both 0 here in this function. There's not going to be a phase or a vertical shift at all, right? So there's no phase or vertical shift, right? So the amplitude would be equal to the absolute value of a, which would be the absolute value of 2, which is 2. The period is equal to 2 pi over b, which would be 2 pi over 4, which is pi over 2, right? So if you remember to find what I'm increasing by each time, we would look at taking the period, dividing it by 4, which this gives me pi over 2 divided by 4, which is pi over 8. Right, so that's what we want to go up by each time, right? So then now we can start plugging in some values. Oops. So first we could look at a typical period of cosine. So if you remember, what we're going to do is look at oops, hang on a minute. All right, sorry about that. One of my sons came in and needed to ask me something, so this video got broken up a little bit, but sorry about that. So what I was looking at was the typical period of cosine. So if you remember, that's going to be in between 0 and 2 pi, where in between you put the bx minus c, right? So in other words, the part that's inside of the trig function. So for us, for this would be 0 less than or equal to 4x less than or equal to 2 pi. Right, so then I can divide both sides by 4. Then I get 0 less than or equal to x less than or equal to pi over 2. Right. So between 0 and pi over 2, that would give me like a typical cosine period, right? So when I'm just going to come over to the side. So when I come over to the side and I make my XYT chart, so we have y equals 2 cosine of 4x. It would be helpful to have a number of endpoints. So remember, I'm going up by pi over 8, right? That's what I'm increasing by, and this is like a typical period. So maybe I want to do like 0, and then we'd have pi over 8, and then we'd have 2 pi over 8, which is equal to pi over 4, and then we'd have 3 pi over 8, and then next would be 4 pi over 8, which is pi over 2. Right? And then maybe what I want to do is just go the opposite way, so the negative direction. So I would have negative pi over 8, negative pi over 4, and then negative 3 pi over 8, and then let me just increase this. And then we'd have negative pi over 2. Right, and this was y equals 2 cosine of 4x. Right, so then I can begin to fill in these y coordinates. Right, so we'd have y equals 2 times cosine of 4 times negative pi over 2. So this would be equal to 2 times cosine of, that would be what, negative 2 pi. Right, which would equal, so cosine of negative 2 pi, right, if we draw, look at my unit circle. So negative 2 pi would be going one way around, so we'd still end up here at the point 1, 0, and cosine is the x-coordinate. So this would be 2 times 1, which is 2. Right? So then, for the next one, we would have y equals, oops, let me use the blue. Break this up. So we'd have y equals 2 times cosine of 4 times negative 3 pi over 8, which is equal to 2 times cosine of, so 4 times negative 3/8 would be negative 3 pi over 2. Right, so negative 3 pi over 2 would be going this way, would land me here at this point, right, which would be the point 0, 1. So cosine is the x-coordinate, so this would be 2 times 0, right, which would just be 0. And then next we would have, y equals 2 times cosine of 4 times negative pi over 4, which is equal to 2 times cosine of, so 4 times negative pi over 4 would be negative pi, which equals, so negative pi, right, would be here at this point, which is the point negative 1, 0. So this would be 2 times negative 1, because cosine is the x-coordinate, so this is equal to negative 2, right? So forth. So we can keep going, repeat this process, fill all these in. So to save time, I'll just go ahead and fill these in. So negative pi over 8 should work out to be 0, and then 0 is 2, pi over 8 is 0, pi over 4 is negative 2, 3 pi over 8 is 0, and pi over 2 is 2. Right, so now I have these, collection of x and y coordinates. So now I can begin, try to sketch a graph here. Right, so here's my x and y axis. See, on the y axis, I'm going to go up by 1 each time, go up to, say, that's 4. And then on the x-axis, we need to increase by pi over 8. So this would be pi over 4, and then 3 pi over 8, and then pi over 2. Right, and then go the negative. Right, and then let's see, I'll switch to green here to graph y equals 2 cosine of 4x, so we can plot some points. So at negative pi over 2, we were at 2. At negative 3 pi over 2, we were at 0. Negative pi over 4, we were at negative 2. Negative pi over 8, we're at 0. 0, I'm at 2. Pi over 8 is at 0. Pi over 4, negative 2. 3 pi over 8 was at 0. And then pi over 2 is at 2. Right, so just try to draw cosine in here. Right, and then I'm going to come in and draw, so the green, just to be clear, that's y equals 2 cosine of 4x. Right, so I'll come in here, let's say in this, let me do like maybe I can do like a yellow color. Oops, I thought I select yellow. Maybe I have to select one of these shades. There we go. Alright, so so I can come in here and now graph the original function, the secant function. So the green function is to help us get there, right? So if you remember right, at all of these spots where cosine crosses the x-axis, these are now going to be vertical asymptotes. Right, and then also remember that where these max and mins are located, that's going to be, if it's a min, it's going to now be a max, right? So if I come in here and draw this function, we get something like this. So we get like this parabola shape, right? Multiple of them. Okay, so then that's our rough graph, right? So then in the yellow, this is y equals 2 secant of 4x, right? So that's how we graph that, graph secant. So it's reliant on what we did in last section, right? So then the next example is similar but a little harder, and I also switched from secant to cosecant just to give another variety of a problem. So remember, for this guy, what we want to do is be able to graph the reciprocal function y equals sine of x plus pi minus 2. Right. So looking at some things from this, we can look at the amplitude. So remember, the amplitude is the absolute value of A, right? So if we want to just identify the pieces here, A is 1, B would be 1 as well, right? Because this would be, y equals 1 sine, oops, I'm not going to have enough room. Let me do this. Y equals 1 sine of 1x minus negative pi minus 2, right? And that will just help me identify, well, let me put in negative 1 pi. That'll just help me identify the pieces, right? So, this one is A, this one is B, this negative 1 is C, and then D is in this spot, right? Negative 2. Right? So then to find all of the pieces, right, to find the amplitude, we take the absolute value of A, which is the absolute value of 1, which is just 1. And then another thing we should know is the period. So the period is 2 pi over b, which in this case would be 2 pi over 1, which is 2 pi. We can also find the phase shift. So remember, the phase shift is equal to c divided by b, which in this case would be negative 1 over 1, which is negative 1. Whoops. Excuse me. I should have included all of that's why I didn't write the 1 originally. Let me fix this. So negative pi, this whole part should have been the c value, right? So this should be negative pi for c, right? So this would be negative pi, right? So what we have is negative pi over 1, which of course is negative pi, right? So the phase shift is negative pi, right? So we're going to go negative pi units to the left, right? So then the next thing that we should note is the vertical shift. So that's equal to d, which would be negative 2 in this case, right? So then, what our tick marks go up by. Remember, we're going to take the period divided by 4, which in this case will be 2 pi divided by 4, which is pi over 2. Right, so not too bad. And then another thing that might be helpful is solving for the typical period. So the typical period, remember, we're trying to solve for this interval, 0 less than or equal to bx minus c less than or equal to 2 pi. So the bx minus c part is here. So we would put in x plus pi here, less than or equal to, and then 0 and 2 pi. So we need to solve for x. So we just need to subtract pi from both sides, and what we get is negative pi less than or equal to x less than or equal to pi, right? So between negative pi and pi would be a typical period, right? So knowing that, we know what the typical period is. We know, what the tip mark should go up by. And also, something else that's helpful is the vertical shift, right? So what we can do is start to make, an XY chart. So y would be equal to sine of x plus pi minus 2. So instead of starting at negative pi, I'm going to go like 2 spots beyond that, right? So if here's negative pi, we'd want to add pi over 2 to it, so that would be negative 3 pi over 2, or excuse me, subtract pi over 2. So then we'd want to subtract pi over 2 again, which would get me to negative 2 pi, right? So then I'm going to add pi over 2 to get negative pi over 2, then add pi over 2 again to get 0, and then add pi over 2 to get pi over 2, and then add pi over 2 again to get pi. And then that would end my typical period, but since I added 2 in the beginning, I'm going to add 2 more. So this would be 3 pi over 2, and then 2 pi, right? And the rationale, the reason why I want to add a couple in the beginning and end, just give me a bigger graph so I get a better sense for what cosecant looks like, right? It's not like an exact science. You could, graph as many points as you'd like. I'm just trying to get like a typical period and then add a couple of ways to the left and right, like we did, similar to how we did to last time, right? So again, we just need to find these values. So I need to plug negative 2 pi in for x and then simplify sine, right? So we'd have, y equals sine of negative 2 pi plus pi minus 2, which would be equal to sine of, so negative 2 pi plus pi is negative pi minus 2. So then, if you need to, it's perfectly fine to draw a unit circle just to have a frame of reference. So if we want to do negative pi, I would be here at this point, which is at the coordinates negative 1, 0. So then, sine is the y coordinate, so sine of negative pi would be 0. So this would be equal to, 0 minus 2, which is just negative 2, right? So then, the next one we'd have y equals sine of negative 3 pi over 2 plus pi minus 2, which would equal, so negative 3 pi over 2 plus pi would be what? Negative pi over 2. So this would be sine of negative pi over 2 minus 2. So negative pi over 2 would be this point, which is, it would be 0, negative 1. So sine of negative pi over 2 is negative 1. So this would be equal to negative 1 minus 2, which is negative 3, right? So you can keep doing that, right, and plugging those in and solving. So again, just to save time for the video, I'm just going to go ahead and fill these in. So we'd have negative 3, and then, so if we plug negative pi in, we get negative 2, then we get negative 1, and then negative 2, and then negative 3, negative 2, negative 1, negative 2, right, for those y coordinates. Alright, so now we're ready to graph sine. So let me just make a xy plane. let's see. So we'll go up by 1s on the y. And then go up by pi over 2 on the x-axis. Right, so then we can begin plotting some points, right? So one thing you'll note, if you remember, is that the vertical shift, was down 2 units, right? So essentially, when we have cosine and sine, remember that typically like that middle line, if you will, it kind of splits up the distance between the two amplitudes, if you will. That is normally on the x-axis, right? But we had a vertical shift down 2 units, so that's now going to be here at -2. Right, so if you want to draw that in, you can, but that's what kind of cuts the graph of sine in half. And then when I plot these points, so we got -2 pi and -2, so I can plot this here. Oops.